Hello, this is Victor at restoringmercedes.com. Today I have a little different video from usual videos that I make. This is the instrument cluster right here from 95 SDL 350 SDL. As you can see, this is the diesel because the RPM gauge, one of the reasons is the RPM gauge is only up to 40, what is that, like 4300, 4400 red line. And this is the gasoline cluster, and as you can see, red line is at 6000. But anyway, the purpose of this video is to show, I want to show the calibration of the gauges, because I had to fix temperature gauge on this cluster. It was erratic and also would get stuck, so I had to get that all sorted out. But in order to get that fixed, I actually had to remove needles, I had to remove the face, the sticker, remove the actual gauge, the motor, take it apart, put it back together, and put all these gauges on. On top of that, I had to remove the little stoppies, the gauge stops. So all of that obviously will need to be calibrated so the gauges are not all over the place. So I'm going to show just a temperature gauge, but then I'll stop the video and do the other ones after all. So now the idea here is that I have this cluster right here that was never touched. It's not working, but the gauges that I need are working. Okay, so I have it all connected and I'm going to power it up, and as you can see, the temperature gauge right here, it jumps, right? Let me just show it. As you can see, it goes up. So I'm just applying and shutting down the power. I have my potentiometer here, a low resistor variable, so I can get the gauge to be about 80. So let me show you that the gauge is at around 80. The camera might not show it very well, but it is as close to the 80 I can get in terms of the straightness of the gauge. And also do it a few times just to make sure that my resistor value is as close as I can get it to remain steadily at 80 degrees. So let's shut this one down. Let's do a couple of more times just to confirm. Okay, so it confirms that it's at 80 degrees. Now I'm not changing the value of my potentiometer. I have to disconnect my probes. Okay, so the probes are disconnected now. Let's take this away, and then we're going to connect it to this cluster. So let's see, what do we have here? I have my positive. So actually I'm doing it a little kind of backwards, to be honest with you, but it's going to work. It's going to work all just fine. Let me, bear with me, I'll connect my terminals. This is for a local customer, so just wanted to show the customer that the gauges was not just put slapped back together, but indeed I tried to calibrate them to the best of my ability. And so here we have it, everything seems connected. So let's see where we are with this gauge. Now this one, this gauge, as you can see, is just a hair over 80. So this one shows like about maybe 82. So we're like 2 degrees off. It's not extremely principal, but might as well just already do it right. So let me try to remove the gauge. I have to actually prop it off again. It's kind of a process. So let's just see. Let me try to do this real quick. I did a different way, but I'll just try to do it while filming. The gauges are very delicate. Obviously you do not want to break anything, and since I'm not in my normal position to do this, like I would just sit down and prop them off and whatnot, but obviously it's very delicate. You don't want to break it off, so you have to have a feel of them. There goes. And you obviously do not want to scratch the face. So the gauge has been removed, and now what we're doing, we're going to put the power on, and obviously the gauge is at 80. So let's see if I can just sort of get it to be at 80 degrees, give or take, and then we'll double check how it works after the gauge is installed. So see, here's at 80. I didn't press it all the way yet, but I'm about 1 degree off, which is, yeah, I'm about like 1 degree off. So if we look again as the center line, it's about 1 degree. It's extremely close to 80. So I'm gonna just try to do it once more. It's because the gauge right now is, also you obviously have to do it with clean hands. So let's just see. Obviously this is sort of a delicate work, lining up the gauge. And let's see. I'm still 1 degree off, unbelievable. Okay, so just once more. Okay, maybe this is going to do it. Yes, sir. Okay, so let me, before it lost its setting, just put it on. And now we're going to see gauge to be at exactly 80 degrees. So I don't know if you can see it in the camera, but it's about 80 degrees right there. Yes, that's about the same as the other cluster would show. So I can push this gauge back in there all the way now. There. Oops, actually I went a little bit too much. Oops. As you can see, I went too deep. Not good. So I need to prop it up just slightly. There, okay. So yes, we're about 80 degrees, give or take. But again, this is not a digital readout. This is just informational. It's more like to tell you if you've heated up or not. As a matter of fact, maybe it would make sense to actually have it at higher setting, just so you know more that on the higher side, on the hotter side than on the cooler side. So that is something. And now once this gauge is done and it's activated, I can put on my little gauge stoppy, a little stopper here. For that I'm going to use pliers because it's pressed in. And you also want to not scratch the surface, but you have to go deep in, because if it also holds the face itself. So the gauge stop is in place, and now the gauge is going to rest at the stop as opposed to just freewheeling, just being all over the place. But to me the result is pretty good. As you can see, this is about 80 degrees and I'm happy with the result. So this particular gauge is not going to move as others. I will explain why. See, the other gauges, they're slow. Okay, so let me just insert this. Okay, so you see the other gauges, they move smooth. This one doesn't. That's the only way for me to get it to fix the gauge, just to make it go fast, no resistance. It's not really a biggest problem because most of these clusters, when they get old, they become like this. The gauges become not smooth, but rather fast. This is a step motor here, we're not touching that. Same on this one, so we're not touching that. Obviously the clock. So these are just the gauges. But the whole gauge works in magnetic field, so it's not going to jump. It's going to be held by magnetic field, and whatever the location it has to be, it is held by a magnetic field. So this is purely made, probably, you know, the Mercedes did it just so they move slow and soft. But once it's the temperature doesn't change much, it's not like your RPM that always changes, so it might theoretically jump a little bit, but these gauges are really not. I mean, this one, yes, this you probably would want to be soft along with this gauge, because these actually do move. This might not be moving a lot, usually it stays 3 and 2, but this would. So obviously these gauges might not be a good idea to do something what I did with this one, but for temperature, the temperature doesn't fluctuate a lot, so if it moves, it's going to move a little bit. So that's the idea. And just to show, like, I have this potentiometer, as you can see, I can change the gauge orientation, as you can see when it moves. Well, this is very rough one, the potentiometer, so obviously I cannot do extremely fine adjustment. It's like, it's extremely rough. It's totally, let me just try to zoom onto the gauge. It is totally not suitable for this, but for test purposes I can do this. I can change the location of the gauge on the dial by changing the resistance. So I'll obviously see the fine point here is very delicate. So as you can see, this is like very low. Okay, so this is it. This is Victor at RestoreYourMercedes.com. Thank you for watching.